All right, we're going to be wrapping up section 7.2 today here, which is looking at how to find the center, the spread, and the shape of sampling distributions for p-hat, sample proportions. Okay, just to draw your attention to what is at the top of this notes page here, this is where we need to find the center, we need to find the standard deviation by doing the 10% condition first, and then before we say it's approximately normal, we then need to do the large counts condition. Then we can finish the problem out by calculating what the actual probability is that they're asking for here. Okay, so in example 3, it says the Harvard College Alcohol Study finds that 67% of college students, so it was like that's what our population is here, support efforts to crack down on underage drinking. The study took a random sample of almost 15,000 students, so the population proportion who support a crackdown is close to 0.67, okay? So they're giving us here that the population proportion, this is the P, not the p-hat, is 67%. Okay, I'm going to just put that right here. That's going to be our parameter. Okay. It says the administration of a local college surveys a simple random sample of 100 students. So that simple random sample of 100 students, I'm just going to write this off to the side, that is the sample size, finds that 62% support a crackdown on underage drinking. Okay, 62%, that is what the p-hat is of that sample that that local college gave. Suppose that the proportion of all students attending this college who support a crackdown is actually 67%, the same as the national proportion. Okay, the question is, what is the probability that the proportion in a simple random sample of 100 students is as small or smaller than the result of the administration's sample? Okay, so what we're really trying to find here is we're looking for what is the probability that a p-hat would be equal to or less than what the administration got when they ran their sample. Remember, their sample was 62%. We want to know if we were to do this again, what were the odds of the sample proportion being that same number or smaller? Okay, so that's what we're after. Now, before we can answer the probability question, though, we need to go ahead and follow through these steps here to kind of create what the center of the sampling distribution would be, and that should fall directly in line with the population proportion. Okay, before we proceed with finding the spread, which is our second step, we're going to show this 10% condition. Okay, 10% condition is going to be 10 times our sample size has to be less than or equal to the population size. So our sample size here was 100. They do not give us how many college students there are total, so I'm just going to fill in what my population is, which is all college students. So I'm going to go ahead and multiply this. Certainly 1,000 is definitely less than or equal to all college students. Okay, so I'm going to check off that we met that condition, and then I can go ahead and move forward with calculating the standard deviation. Okay, I'm going to go ahead and write the formula down here, but you would not need to write this formula on the AP test, but you do have to show the substitutions into the formula here. Okay, so I'm going to fill in. Now, remember, the P is the population parameter, or the population proportion, rather. Okay, that's this parameter, the 0.67. These are not p-hats. These are parameters. Okay, so the P is 0.67. The 1 minus P would be 0.33, and I'm dividing that by our sample size, 100. That's going to give me the standard deviation of the sampling distribution for p-hats to be 0.0470. Okay, I'm going to circle that. We're going to need that. I'm going to go ahead and circle what our mean is. We're going to need that up there. Okay, step 3. This is where we want to be able to say that the shape of the distribution is normal. Okay, for us to be able to do that, we need to first confirm that the large counts condition has been met. Okay, the large counts condition says we have to show our substitutions that the number of expected successes is at least 10 and the number of expected failures is at least 10. Okay, so we're going to fill in 100 for our sample size, 0.67, that is the population proportion, and we need to show that that comes out to greater than or equal to 10. We also need to show that 100 times 0.33 would be greater than or equal to 10. So, all right. It certainly met those two conditions, so then I can go ahead and conclude that this is definitely approximately normal, okay? And this little symbol here with these 3 dots is a symbol in math that means therefore. So you could put that, therefore, we're saying this is approximately normal. So I'm going to go ahead and summarize all these components here. We did this back in chapter 2. We use the N for the shape, normal, followed by the center, and followed by the spread. Okay, this is what we would want to use when we get down to step number 4 and we actually are ready to answer the probability aspect of this problem. Okay, so we're going to go ahead and say we're looking for the probability that a sample proportion would be 62% or less. I'm going to use the normal CDF feature on the calculator with my 4 inputs. I'm going to go ahead and fill these in here. Okay, keep in mind this was a less than problem, so we're going all the way back into the left tail here. Okay, I'm going to go ahead and just draw a nice little picture. This is added extra communication that the graders really like to see. Okay, I'm getting this from the fact that we know the center, the mean, should be 0.67. Here's what I'm trying to find, anything to the left of 0.62. Okay. And so we would fill in 0.62 actually as our upper, and then I can pull these straight here, 0.67, 0.0470, and I end up getting as my answer that we're looking at roughly 14.38% chance that if they were to repeat this and do another sample, they would get either 62% or less of those students saying they support a crackdown on underage drinking. Okay, on to the last page, which is actually our last example. I keep putting the same summary information up here. Please know that none of this information in this order is provided for you apart from you are given these 2 formulas on the formula sheet, but you have to know what conditions kind of go with each of these components here. So let's wrap this up with our last example. Planning for college. It says the superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a 4-year college or university. Suppose that 80% of all middle school students in her district are planning to attend a 4-year college or university. Okay, now keep in mind here, what this particular superintendent is interested in isn't necessarily information about all middle school students in the country. She's really just interested in the middle school students who are in her district, okay? So when it says, suppose that 80% of all middle school students in her district are planning to attend a 4-year college or university, if the middle school students in her district are our population, then that means 80% is actually a parameter. Okay, it says here, please keep in mind that this particular district has 2,000 middle school students in it. Okay, so the first question is, what type of measure is 80%? Okay, well, we said 80% was measuring all of the middle school students in her school district who were planning on attending college. That's the proportion. So this is a parameter. Okay. And we're going to say it is a population proportion, to be specific here, of middle school students planning to attend a 4-year college in this district. Okay, and so I'm going to label that with a P, not a P hat. Okay, part B says, okay, well, suppose the superintendent takes a simple random sample of just 125 of those middle school students. Now, keep in mind, there are 2,000 actually in the district, but she's only taking a sample of 125. That's what the sample size is. We want to describe the sampling distribution for the sample proportions. Anytime you are asked to describe a distribution, you need to be saying what the shape is, what the center is, and what the spread is. And so what we're really after is we want to be able to say, hopefully, that if it meets that large counts condition, it's approximately normal. We also need to be able to say the center and the standard deviation, the spread. So that's what we're after when we're asked to describe. We have to justify each of our statements, though, by checking the appropriate conditions. Okay, so our first step here is going to be to get the center. There is not a condition that you have to show for the center, but we know this is the formula that's on the formula sheet. So we're going to grab that population proportion of the 80% of those 2,000 students are planning on attending a four-year college or university. We're using that as our center. Okay. Number two, for our spread, we have to first show that the 10% condition has been met. So I'm just going to show that here off to the side, 10% condition. Okay, now 10 times, keep in mind the sample size. Okay, 125 is the sample size. The population size is the 2,000. Okay, so that's helpful for me to know that there are 2,000 middle school students total here. So I need to make sure that if I'm taking a sample size of 125, because I'm not going to be replacing them in between, that I'm not taking out too much of a chunk that's going to affect that independence. Okay, and so this looks good. I can check off that I've met that condition, so I'm going to go ahead and move forward with my formula. Again, this would be a formula that you could certainly look up on the formula sheet. Okay, so no need to memorize it, but you at least need to know that you have to use this formula. Okay, we would plug in 0.80 for the P, 0.20 for the 1 minus P, and this gives us the spread to be 0.0358. Okay, all right, and so then our last part here would be the shape. If we're going to do the shape, we need to show that the large counts condition has been met. So I'm going to do N times P, have to show that that is greater than or equal to 10. That comes out to 100, so that feels good there. Okay, let's try this next one here. 125 times 20 needs to be greater than or equal to 10. That's 25, so we met that as well. Okay, so then I can conclude, therefore, approximately normal. Okay, so I can go ahead and summarize this. I can put my N, I can grab the center, 0.80, I can take the spread here, and now this would be any information that I could then use if they ask me a probability question, which is what we have here in part C. Okay, and this is the last part of this problem. So it says, what is the probability that the sample proportion that the superintendent gets from just this one sample is going to be within 5% of the true proportion? Now remember, the true proportion, we were told in the problem, was the 80%. So we're looking for within 5% of that 80%. Okay, we want to know what are the chances of the p hat being either 5% greater than 80% or 5% less than 80%. So it creates this window between 75 and 85%. I'm going to go ahead and use the calculator feature. Okay, my lower would be the 0.75, upper 0.85, and then I'm just pulling these right here. Okay, we type that into the calculator. We roughly are looking at about an 83.75% chance that for her sample proportion, she would end up, that sample proportion would fall somewhere between 75% and 85% of middle school students saying that they are planning to attend that